Welcome to Pomodoro Joe for Saturday, September 2nd, 2023. Today we're doing LeetCode problem 2707, extra characters in a string. This is a medium problem. You are given a zero-indexed string, S, and a dictionary of words, dictionary. You have to break S into one or more non-overlapping substrings, such that each substring is present in dictionary. There may be some extra characters in S which are not present in any of the substrings. Return the minimum number of extra characters left over if you break up S optimally. All right, I don't really know what they mean by breaking up S optimally means. I'm guessing they're looking for optimizing for the minimum number, but I don't really know. Okay, so we have an example. LeetCode dictionary. We have LeetCode and LeetCode. Well, this has an S in there, so we can break it up into Leet and code with an extra S. And that means we return 1. Cool. Say hello world, dictionary hello world. Looks like we have say, so we have 3. Okay, so this isn't too bad. We'll put 25 minutes on the Pomodoro timer and we will get started. So I think for this, let's see, how will I approach this? Well, I think I'll look at the very beginning of our string, look for some character. Now, it'd be nice to know if I had words in my dictionary that start with that character. So maybe the first thing I'll do is actually break up my dictionary or reformat my dictionary from being a list to being an actual dictionary where the key is the start letter and the value is a list of all the words in my dictionary that start with that letter. So I think that's what I'll do. So then I can take my first letter of my string, look for any words in my dictionary that start with that same letter, see if I can find a match. If I find a match, then I can just recurse on the rest of the string. If I don't find a match, that means that I've got this character, I can't find a match for it in my dictionary, so I'll just move on to the rest of the string after that character and add 1 to my result, saying I have 1 extra character I can't use. Okay, so that to me means I have to reformat my dictionary into some mapping of first character to list of words, and then I'll need to create probably a recursive function that will take the start index of where am I in my input string, and then it will return the value basically for that substring, the min extra character for that substring. All right. Yeah, I think that's a good approach. So, step number 1, let's convert this dictionary into something that we can use a little bit easier. So I'll have a word map here. So make a note actually. So the key will be the start character, and the value will be a list of words that start with that start character. All right, so my word map, this will be a default dictionary. And the value in my default dictionary will be a list, so I'll initialize my default dictionary as a list type of default dictionary. Next, for every word in our dictionary, let's see, we'll grab the first character of that word, and then we'll add that word to our word map at that character. So word map for this word at index 0, that's the first character of the word, we'll append this word. Great, so now we have our word map. And I'll just close this gap here because we don't need this. All right. Next, let's define our recursive function. So define min extra char research, extra char recurse. So for this, I think I'll just take a starting index. Where are we starting in this string? So let's have a start index here. So I could be passing in the string itself, but I think it'll be a little bit more efficient to pass in the starting index so we don't have to create a whole bunch of new strings every time we recurse. All right, first thing we do whenever we have a recursive function, let's define our base case. When do we stop recursing? Well, if our start index is out of range, well then we're done. So let's do that first. If our start index, that's if it's greater than or equal to the length of our string, that means that this start index is out of range of our string and will return 0. There are no extra characters. Next, we have some recursive cases. So for this, I will go through every word in my dictionary that starts with the same character as the start of my string, or the string at this start index. So let's actually define our start character here. Our target character, that's going to be our string at the start index. All right. Then for every word in our word map for this target character, let's see, maybe I'll call it start character. I think that's better. All right, so for every word in our word map that has this start character, or that starts with this start character, let's just check to see if our string from the starting index to the length of this word, if they're the same. So is this word the start of my current string? If they are, then we can recurse. If they're not, then this word won't actually work in our, I guess, substring detection or appending substrings. So let's first find the end index for this word in our overall string, in our main string. So our end index, let's see, that's going to be our start index plus the length of this word. Okay, so now let's check if our word is the same as our current string here, as the current start of our string. So this will be from the start index to our end index. So if you're not familiar with this, this is string slicing. So basically I can use the square brackets, pass in my start index and my end index. Now this will not include the end index itself. So this goes from the start up to and including end index -1. So if my word is the same as my current string, which is from this start index to this end index, well then we found a potential word that we could use, and then we can recurse. So if my current word does start my current string, then this is one option. So I'll call this option, and we can do a recursive call on what's left of our string here. So we'll just use this word, and then we'll recurse on the rest of the string. So we'll call our min extra char recurse, and we'll start at the end index. All right, now I have to compare this result, whatever we get back from this recursive call, to some current result. Now I don't keep track of my current result here yet, so let's do that. Let's have some result. And we'll define it as something really big because I'm looking for the minimum. So I want to find something smaller than my default, which in this case, we'll just make it infinite. So now we'll check, is this option better than my current result? If it is, then my new result will be this option. So we'll take the min of this result, or the option. All right, so again, we're checking every word that starts with the same character as our current string. If we find something that starts with the same character, then we'll check to see if that word is actually the start of our current string. If it is, then we can lop that off the front of our current string, and we can do a recursive call starting at the end of our current word, going to the end of our current input string. All right, now out here, we have one more recursive case that we haven't discussed. What if this start character has no words in our word map? Or even if it does have a word in the word map, maybe there's no word in the word map that actually matches this condition where it is the beginning word in our current string. So in that case, we need to skip this character, this current start character, and just do a recursive call on the rest of our string after we skip this character. How do we skip this character? Well, for that, we can just do a recursive call. I'll grab this. We can do a recursive call starting at the next index. So we'll do start index +1. So we've skipped a character. We just start at the next index. Now, because we skipped a character, our result will be increased by 1. So it'll be 1 plus whatever this is. Now I need to store this. This is one option. So I go through all my words that possibly start my string. These are our options so far, and we've already chosen the minimum or our best option out of all those words. Now this is an alternate option. Let's skip this character and do a recurse on the rest of the string. So our alternate, I'll call it alternative. So this is our alternative option. We just skip this character and we recurse on the rest of the string. And now out here, we'll return, well, what gives us the best result? Our current result from this loop or our alternative result? All right, so whichever one gives us the best result, we'll return that. If our result from doing our recursive calls here give us the best result, we'll return that. If our alternative gives us the best result, we'll return that. I think I might have misspelled this, so let's just copy and paste. And then finally, we do need to kick the whole thing off by making our initial recursive call. So we'll just return this whole thing, starting at index 0. And now one thing I'm not doing is caching our results or using dynamic programming. This is probably not going to run in the runtime we need, just because we'll be doing a lot of the same recursive calls over and over and over again. We'll just run this, see if we pass first. Looks like I missed something. What did I miss? Oh, this whole thing was in this if. All right, I had an indentation problem here. Let's unindent all of that. There we go. Try this again. Okay, it works. Now, I'm guessing it's not going to pass in the runtime we want, so I'm just going to jump ahead and add @cache. So if you watched my videos before, you're very familiar with this. @cache is a function decorator. It's found in the functools library. So what cache will do is the first time you call this function with a given input, it will run this function and then it will cache the result. When you run this function again with the same input, instead of running the function, it will just return the cached result. So this will save us a ton of time. All right, we'll submit that, see how we do. And we pass. And we do, holy smokes, we do really well. We beat 99% for runtime and 55% for memory. That is better than I could have expected. Wow. All right, I'm pretty happy with that. I don't think I'll make any changes. Okay, well, I guess that's it for me. Let's go back here and check this out. This is 2707, extra characters in string. Check this one out. It's super fun. And if you like this video, please like. If you like my videos in general, please subscribe. And hey, have a great day. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.